So we are into our next segment. Next segment, that is respiratory volumes and respiratory capacities. What are these two? What is respiratory volume and what is respiratory capacity? Obviously, so we are into discussion of breathing and exchange of gases. The air, the volume refers to here. So this one is the amount of air. So respiratory volume will be amount of air accommodated in lungs in respiratory cycle. In respiratory cycle, what is the volume that we are speaking of here? So that is the volume of air where in the lungs, right? So amount of air accommodated in the lungs in a respiratory cycle. What are the events that are included in the respiratory cycle? You see, you have the inspiration, and then we have the expiration. These are the important events that are happening in the respiratory cycle, isn't it? There is a process of inspiration and then there is a process of expiration. So these processes are normally happens in normal quiet breathing. Normal quiet breathing without, when you are not thinking anything, unconsciously. When you are breathing, you have inspiration and expiration. Sometimes these breathing patterns can be altered during the stressful situation, at the times of danger, right? So here this inspiration can be forced inspiration, right? It can be forced inspiration and there can be forced expiration, isn't it? There can be forced inspiration and there can be forced expiration. At what times? During stressful situations, right? During stress and at the time of danger. So at the time of danger, there can be forced inspiration, there can be forced expiration. As a matter of fact, altered breathing, right? The normal breathing pattern has been altered. So this is the forced inspiration, forced expiration. Is the value remains same here? Obviously, the amount of air that is taken in the case of forced inspiration or expelled in the case of forced expiration obviously varies, obviously changes, right? So that is what we are doing in the respiratory volumes. You are trying to calculate how much of the air that is accommodated in the lungs at the time of inspiration, at the time of expiration, during the time of forced inspiration, during the time of forced expiration. Right? You are trying to measure all these values. What is the purpose? Why do we need to measure these values? So that you would know the health of the lungs, right? You would know the health of the lungs, whether the person have well functioning respiratory system in his body, so that you will have efficient area. You see, when you see the ECG, electrocardiogram, why do we do that? To assess the function of the heart. Here you are measuring these values. How do we measure these values? If you recall our previous lesson, right, in the mechanism of breathing, what is the instrument that we have? The instrument is spirometer. Right, the instrument is spirometer, very important in NEET in the NEET examination. What is the instrument to measure this respiratory values? Spirometer is the instrument, right? And here we also have to recall one more important point that we have discussed, right? How many times normal quiet breathing happens in the case of human beings, right? How many times? So this is 12 to 16 times. 12 to 16 times per minute. Right? This is 12 to 16 times per minute. When you measure with the spirometer, the quiet breathing. The quiet breathing will be 12 to 16 times per minute. That means, right? That means how much of the air will be accommodated in the lungs in total, right? So when you take these values, you would know how much of the air is accommodated, how the inspiration process, how much of the air, how in expiration process, how much of the air. So by doing all of these, by calculating the normal quiet breathing, forced inspiration, forced expiration, you will have an elaborate idea. You will have an elaborate idea about the person's breathing patterns. Okay, and we will also take one more important point for the NEET exam. So spirometer is one important point. 12 to 16 times is the other important point. And all these values, breathing patterns, are regulated by two important centers in our body. One is the medulla oblongata. Yes, medulla oblongata is one, isn't it? Followed by what? Pneumotaxic center. So where it is located? It is located in the pons of the hindbrain. As a matter of fact, these two are part of the hindbrain of the body. These two are regulated by all these breathing mechanisms, right? Inspiration process, expiration process. This is an introduction for the respiratory values. Now we shall see what are the different kinds of respiratory values that are present. Okay, so that is our next discussion, different respiratory values. Now please pay attention, it's very important and very confusing as well in the respiratory system lesson. First, we have, as a matter of fact, four important values. Four important values, and one more value will also be considered apart from this, and that I will mention. These are the four major important values. First one, the first value that we need to be studying is the tidal value. There is something called the tidal value, and it is mentioned by the acronym TV, right? So tidal value TV acronym. So what is the meaning of tidal value? The meaning of tidal value is, so the amount of air accommodated in the lungs during quiet breathing, right? The amount of air, tidal value. So here, during quiet, what do you mean quiet breathing here? So when you are normally doing your breathing without being conscious of it, right? So here quiet breathing means without being conscious. Yes, without being conscious. That is the tidal value. How much of the air that is there? How much of the air is? That is 500 ml. 500 ml. So that is 500 ml of inspiration, 500 ml of expiration. You see? So a total of tidal value, how much of it is? 500 ml. 500 ml is the tidal value. And how many times per minute do we do this? This you will do for 12 to 16 times. Just now I have explained. So this inspiration expiration process, with this tidal value inspiration expiration process, how many times? 12 to 16 times. And if you take the volume of this, approximately how much you would get is, you would get approximately 6,000 to 8,000 ml per minute, right? This much of the air is accommodated in the lungs per minute. This much of the air in tidal value, very important. So the tidal volume is 500 ml, 6000 to 8000 ml of air. 6000 to 8000 ml of air is accommodated in the lungs during quiet breathing. During quiet breathing. Does it change? Obviously, it will change. What is the next set of value that we have? What is the next set of value that we have is next, that is called as the inspiratory reserve value. Inspiratory reserve value, we are taking the first letter of each word, that is IRV is the acronym, inspiratory reserve value. So what is this? What is this? I have told you previously, in the air that is forcibly that is taken. At times you need additional volume of air. Additional volume of air during the times of stress. Right? More amount of air needed to be in the lungs. In the lungs, in such a situation, how much of the air that can be taken in, right? So this is forced air in addition to tidal volume, right? You see, you are taking this in the times of stress, that is forced air into lungs, you can say, into lungs in addition to the tidal value, that is already there in the quiet breathing. Over and above the tidal value, you are taking the additional set of air. How much of the air that is there for inspiratory reserve value? The volume of air that we are taking in here is 2500 plus 2500 to 3000 ml. 2500 to 3000 ml is the amount of air that can be taken in times of stress, in the forced breathing. That means at the time of stress, how much time you can take it? That is 2500 to 3000 ml. All around at the process of inspiration. By the process of inspiration, how much you can take in? So 2500 to 3000 ml plus 500 ml, right? So this is for the inspiration, right? Total inspiration value. Total inspiration value. If we take how much it is? It is tidal value plus IRV. How much it is? It is 500 plus 3500 ml, a maximum of 3500 ml. 3500 ml that can be accommodated by the process of inspiration. Right? So a total of 500 plus 3500. So this is a maximum of 3000 ml. I'll just erase this and I'll write again. Right? So maximum of 3000 ml, a total of 3500 ml you are getting. So by the process of inspiration, so here 500 inspiratory reserve value, maximum of 3000, you are getting 3500 ml. So total inspiratory value, and this is otherwise can also be called as inspiratory capacity. So we're going to come back to this again for now. So this is total inspiratory value can also be called as inspiratory capacity. That means what is the total capacity? What is the total inspiratory capacity of lungs? Right? What is the total inspiratory capacity of lungs? So that is 3500 ml. Right? How much of the air in total the lungs can accommodate is 3500 ml. That is inspiratory capacity. that is total inspiratory value. If I say inspiratory reserve value, you would get this one. If I say tidal value, you would get this one. If I say what is the total inspiratory air, what is the total inspiratory capacity? The inspiratory capacity will be 3500 ml. So what we have seen so far? So we have understood two values and one capacity, right? Two values, tidal value we have understood. So this is in the quiet breathing. Inspiratory reserve value we have understood. This is in the forced inspiratory value. So that is 2500 to 3000 ml. And we have also learned one capacity related to the inspiration. That is inspiratory capacity. So the capacity of the lungs at the time of inspiration, right? That means regardless it is normal or quiet. If we include those two inspiratory values, you would get the inspiratory reserve value, right? So I am just erasing this. So hopefully we are clear. So 4 values I said, we have discussed 2 values. We have discussed 2 values only. Value 1, tidal value, and we have seen the inspiratory reserve value. Please do careful about the values and capacities. I am not including this. So this is part of the capacity, right? So this is inspiratory capacity. Inspiratory capacity, right? That is inspiratory capacity. How much of the inspiratory capacity? We have included TV plus IRV. TV plus IRV is the inspiratory capacity, isn't it? Yeah. So I am erasing this. So please don't get confused. So inspiratory capacities, 2 values. We will see other set of values as well. So other set of values. So what is the third value? The third value that we have is the expiratory reserve capacity. Expiratory. So I am writing 3 here, right? Tidal value, inspiratory reserve value. Now we have the expiratory reserve value. That is expiratory reserve value. How much of the value that can be expired? So this one. So forced air out of lungs. In addition to the tidal value, right? So in the inspiratory capacity, in the inspiratory reserve value, we have seen amount of air that is into lungs over the tidal value. And here what you are taking in, you are taking the air that is expelled out, forced air out of the lungs in addition to tidal value. In the tidal value, how much of the air you would expel out? How much of the air that would expel out? 500 ml of air, obviously. And in here, how much of the air that is expelled out is 1000 to 1100. 1000 to 1100 ml of air. ml of air is expelled out, right? So this is the expiratory reserve value. Related to this, one more capacity is included. So that is expiratory capacity. That is expiratory capacity. What is expiratory capacity? Expiratory capacity is total air expelled out of lungs. Right? So total amount of air expelled out of the lungs in the tidal value and in the forced breathing as well. How much of that you are expelling? You see, so this one is actually, what is this? Tidal value plus ERV. Right? So that is expiratory reserve value. Tidal value plus expiratory reserve value, a total of 1600 ml. Right? See, so this is equivalent to this one. I am writing that here as well. So this one is actually TB plus ERV. Right? So that is total air expelled out of the lungs. Total air expelled out of the lungs. How much of it? 1600 ml. 1600 ml. That is one more capacity. Yes, that is expiratory reserve value. So these are related. These are related to the lungs capacities. What is one more volume that we have? One more volume that we have is the reserve value. The reserve value. The reserve value. So this is simply RV. Simply that is RV. What is this RV, reserve value? So this is the amount of air that is always there in the lungs. Right? So this is air always present in the lungs. That means you can never empty your lungs completely. Right? You can never empty your lungs completely. Right? So you cannot force out the air until your last ml of air. You cannot do that. You cannot. Why can you not do that? The nature has taken care of it, because if you do that, the person will collapse and dies. Right? So lungs are inflatable bags. Right? So if you totally expel it out, and you don't have any reserves, then the person will collapse and die. The lungs will collapse and there is no exchange of gases. The person will die. So that is why this air that is always present. You see how much of it? So this one is 2200 ml. So where is this difference of value we are getting? In the respiratory reserve value, how much you have got? 2500 to 3000. Here only you are expelling at the maximum, even after forceful breathing. You are only expelling 1600 ml. 1600 ml, and in addition close to you have 1400 ml. And so that is where reserve value is 1200 ml. 1200 ml is the reserve value. Right? So these are the different kinds of values that are present. And we're going to come to the capacities one more time. So inspiratory capacities and expiratory capacities are related to the lungs. There are furthermore some more capacities. I'm going to write those capacities as well now. Right? So to sum up, we'll just sum up the volumes one more time, and we'll have to mention one more volume which is related here but not that frequently mentioned, because these four are the major values. Right? And one more value that is called as dead space value. One more value that is called as dead space value. So this is normally not used to account for the person's health. So what is this dead space value is? So this is the air that is present in the conducting zone. Right? So this is the air present in the conducting zone. So we have this respiratory pathway, we have this conducting pathway, right? So the air that is present in the conducting zone, right? It does not actually reach the exchange sites of alveoli. How much of the air that is there here is close to 150 ml. What does that mean here is, so if you take in 500 ml in the tidal value, so 150 ml stays entrapped, right? In the conducting zone. Actually 350 ml reach alveoli, right? So the functional value that is reaching the alveoli is just 350 ml, and 150 ml is lost in the conducting pathway. 150 ml is lost in the conducting pathway. So this amount of air that is there in the conducting air passageways, that is called as dead space volume. Normally it's not counted when we take up the respiratory volumes. Four volumes. I'm gonna erase this. I'm gonna write these four volumes one more time for your benefit. Because of the space issues, I keep erasing these volumes. Please don't get confused. And if we have larger boards, I will have presented all of these in one board itself. Because of the space issues, I keep erasing this. I'll just write one more time because of that. So we'll just keep those two capacities together. I'll write the volumes one more time for your benefit. Right? What is the first value? Tidal value. How much is the tidal value? 500 ml, isn't it? 500 ml. Then we have inspiratory reserve value. So what is the inspiratory reserve value? This is over and above the tidal value. What is the amount? The amount is 2500. 2500 plus 2500 to 3000 is the maximum. Right? 3000 ml. If you include these two, right? If you include these two, what you would get? You would get the inspiratory capacity, isn't it? So this is the total. So don't forget. So when you say inspiratory capacity, the amount of air the lungs can take in, right? Amount of air the lungs can take in the process of tidal value, in the process of inspiratory reserve value. Okay. And what is the next one? The next one that we have is expiratory reserve value. Expiratory reserve value, how much of it? This is 1000 to 1100 ml. Right? 1100 ml. So this one is expiratory capacity. What are we including here? We are including tidal value and inspiratory reserve value. You see the tidal value in the 500 ml, you are including the inspiration and expiration as well, because in our respiratory system we only have one pathway for inspiration and expiration as well. We don't have a separate pathway for inspiration and a separate pathway for expiration. So it's not like that. That is why it is 500 ml both for inspiration and expiration as well, right? So when you say, I'm going to present that in one more time in a graphical pattern. So please do remember both of these values. Inspiratory value is 500 ml, expiratory value is 500 ml, but we are not taking 1000 here because of the same pathway that we have. Okay, so how much of the value here is 1000 to 1100 ml. 1000 to 1100 ml is the inspiratory reserve value. So these three are related with the actual respiratory cycle, the allowing the air into, allowing the air out of the lungs. What is the other value that we have? The other value that we have is the reserve value, right? Respiratory reserve value, or simply we will write the RV, respiratory reserve value, and this one is 1100 ml to 1200 ml. Very easy, right? 1100 to 1200 ml, 1200 ml. So the difference here, the difference between this and the difference between this is the reserve value, right? So this, as a matter of fact, can be explained if we had been in a classroom situation with the help of a balloon, right? That can be explained. I'm going to come to that now. So hopefully we are clear about the capacities. And keep coming back to these values again and again. And now what do we see is, so we'll see the capacities. Furthermore, still more capacities. How many capacities we're gonna count? And please to remember the less frequently used volume as well here. the less frequently value. Just now I have explained, right? So that is dead space value. It is normally is not counted in your pyrometer respiratory health studies. So that is 150 ml. 150 ml, which is always present in the conducting zone itself. Right? Now what is the other capacities? Third one we are taking up. Yes, third one is functional residual capacity. Functional residual capacity. So what is this functional residual capacity? Is the air which is used for functional purposes, which is always there in the lungs, I just erase these examples, and this I'll come back to this in the form of a diagram. Okay. So I am taking as a balloon as an example. So we have this a balloon. So we all know the balloon, right? So you can inflate this balloon. So I am taking a balloon as an example. So balloon as a representation of lungs, and this can be inflated just as the same way the lungs can be inflated. Right? So here, how much of the air this balloon can accommodate? We'll see how much of the air this balloon can accommodate by blowing air into this. So normal quiet breathing. So as we are saying, there is always some amount of air in the lungs, right? So I'm inflating this balloon. Yes, there is always some amount of air in the lungs. Okay, so this one will be the reserve value. That is always present in the lungs. How much of it? That is maximum of 1200 ml. 1200 ml reserve value, right? And when you forcibly expire, how much that you can expire? Right? So this is the value that I am taking here. Okay, so what is this value? So this one is actually expiratory capacity, expiratory reserve capacity, ERV. Expiratory reserve value. How much of this expiratory reserve value? Expiratory reserve value that we have is 1000 to 1100 ml, isn't it? 1000 to 1100 ml. Over and above this, what we have is, so over this, yes, so here what you get is, you get the tidal value. How much of the tidal value? 500 ml. You see, why did I take the tidal value here? That means the air that is always present in the lungs, right? So during the quiet time, the air that is always present in the lungs is close to how much? So ERV plus RV. So that is 1100 plus 1200, 2300 ml. Right? 2300 ml. So functional residual capacity is ERV plus RV. So that is 2300 ml. Right? This much of the air is always present in the lungs during the quiet tidal value. That means when you are sitting, when you are doing nothing, when you are sleeping, right, without doing any work. As a matter of fact, a forceful work, kind of running, exercising, or being run away from a chasing dog, and all of this. At that time, what is the air? Except those times, in the normal times when you are sitting not doing any work, in the normal time, how much of the air that is being exchanged? 500 ml. And is this disturbed? Right, this volume of air, is this disturbed? No, this is always present at the time of the tidal value. When we are regularly breathing in or breathing out, this much of the air that is always present. Right, this is not being disturbed. This is always present in the lungs. Right, and what is the inspiratory reserve value? Inspiratory reserve value means you are taking the air over in addition to the tidal value, right? In addition to the tidal value, that means I am further inflating this balloon, right? That means I am further inflating this balloon close to. So this is inspiratory reserve value. So that is 2500 to 3500 ml. 3500 ml. Right? So this is the additional volume of air that we can take at the time of inspiration. So this is the normal inspiration process. Right? So you have inspire and you have expiration. You have inspiration and expiration. So this is the range that is keep happening here. Right? Inspiration and expiration. 500 ml. So here the air keep getting exchanged. Here the air keep getting exchanged at the tidal value. And